All right, for this one, the process is still the same. You'll notice that there is an x on the other side of the equation. The radical is already isolated. So the first thing that we're going to do then is raise both sides of the equation to an appropriate power. Now this one is a square root, so that power would be a 2 because the index on a square root is a 2. So I'm going to do parentheses there and a 2 power. Now on the right side of this equation, the effect of that is just that the square root gets canceled, so I have 7x plus 15. On the left side of the equation, x plus 1 squared means x plus 1 times x plus 1. So that means I have to distribute, or FOIL, or whatever you want to call it. So x squared plus 2x plus 1. This gives us now a quadratic equation that we have to solve. So the process for solving a quadratic equation is a little bit different than a linear. Rather than just trying to get the x alone on one side of the equation, we're going to try to create a 0 on one side of the equation. So for this one, I want to create my 0 on the right side of the equation. I'll do that by subtracting 7x from both sides and also subtracting 15 from both sides. And then from here, the first thing you should always be thinking of is factoring. So I'm going to try to factor this. I need things that'll multiply to make a negative 14 and add to make a negative 5. So that would be a negative 7 and a positive 2. Now I'll set each of those factors equal to 0 and solve them. And at this point, you should be able to do that part in your head. So x minus 7 is 0 would give you x equals 7. And x plus 2 equals 0 would give you x is negative 2. Now we do have to check our answers, of course, because there is a possibility for extraneous solutions. This time, since we have two answers, we have to check both of them. And we need to check them in our original equation. So that would be the original one up here before I squared both sides. So I'm going to check x equals 7 first. So I'm putting in 7 in place of x. So I'd say 7 plus 1 is equal to the square root of 7 times 7 plus 15. Now this time I do have things to simplify on both sides of the equation. So I'm going to work on them simultaneously. 7 plus 1 is 8. On the right side of the equation, before I can deal with the square root, I need to do everything inside it. So 7 times 7 is 49. So now I've got 49 plus 15. So I have to add 49 and 15. So 49 plus 15 is 64. And at this point, I can see that that is in fact true. The square root of 64 is in fact 8. Now I'll check my other solution, my other apparent solution. So I've got x is negative 2. So I'm putting a negative 2 in place of all the x's in the original equation. So I would say negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. So again, I've got things to simplify on both sides of the equation. Negative 2 plus 1 is negative 1. On the right side, I've got 7 times negative 2, which is negative 14, plus 15. Then I need to simplify what's inside the radical next. So negative 14 plus 15 is a positive 1. And this now says that the square root of 1 is equal to negative 1, which is in fact not true. You may be thinking about all the times that I told you that you had to use a square root. But just to clarify, that's if you're taking the square root of both sides of an equation to solve it, then there would be a plus or minus on your radical. But this type of equation had the radical in it. So we only consider what we call the principal square root, which is the positive square root for this one. So that means I would have to discard negative 2 as an answer. It's not really an answer to this equation. So I'd have x equals 7 only. Now you try the next example in the Google form.